All right, this video we're continuing with equations of quadratic form. Let's look at the first one, example A. You can see that if we let u be equal to the middle term, the square root of x, then when you take u squared, it would be the same as saying the square root of x squared. And of course, when you square a square root, you just get what's inside the square root, so you end up with the term out in front. So it does look like u substitution would work here to turn this into a quadratic equation. So we'll end up having u squared minus 3 times u plus 2 is equal to 0. And then we can try to factor this. So we'll have u, and then factors of 2. So we'll have 2 and 1, and then they both need to be negative because the sign on the right there is positive. So it means 2 of whatever sign is on the left, and that's 2 negatives. Okay, so that's factored. Now we have two factors that are multiplied to equal 0, so we can apply the zero factor property. So we'll have u minus 2 is equal to 0, and u minus 1 is equal to 0. Of course, that just gives you that u is 2, and that u is equal to 1. Now don't forget that u is the same as the square root of x in this problem. So we'll have the square root of x is equal to 2, and the square root of x is equal to 1. So of course, if we square both sides of the equation, we'll get the answer x is equal to 4 and x is equal to 1. Now we need to check our answer because we need to make sure that when we squared at the end there to solve for x, that we didn't introduce answers that don't work in the original equation. So we need to check our solution then. Okay, so let's plug in 4 and see if that works. We'll have 4 minus 3 times the square root of 4 plus 2. Well, that's 4 minus 3 times 2 plus 2. So that's 4 minus 6 plus 2, and that of course is indeed 0. All right, let's try x equals 1 then. We'll have 1 minus 3 times the square root of 1 plus 2 equals to 0, and then of course that'd be 1 minus 3 plus 2. And of course 1 and 2 make 3, minus 3 does indeed give you 0. Okay, so it appears that both answers check out, so the solutions are 1 and 4. All right, let's take a look at example B then. For example B, it may be complicated looking, but if you look carefully, this is very similar to A, right? Because if you squared this radical, you would end up getting just x squared minus 3. So again, it's sort of the same as example A, so basically we'll use u substitution on it. And as always, we let the middle term be equal to u, so we'll have u is equal to x squared minus 3. And therefore, u squared would just be equal to what's underneath the radical, or x squared minus 3. Okay, so let's go ahead and plug in then the u's to solve this problem. So u squared would represent this first term, or first two terms. So we'll have u squared minus 4 times this piece, which just is u, minus 12 is equal to 0. So let's try to factor that. So parenthesis equals to 0. We'll have u and u. Factors of 12, that would subtract to give us 4. Well, that would be 2 and 6. So 2 and 6. The fact that it's negative on the right means we need a sign of each. And the bigger one should be negative because, of course, we want to have the middle term turn out to be negative. All right, so we have u plus 2 times u minus 6 is equal to 0. Let's go ahead and use the zero factor property. So we can say u plus 2 is equal to 0 and u minus 6 is equal to 0. So that'll give us u is equal to negative 2. And finally, u is equal to positive 6. All right, but don't forget we have to back substitute, right? So we know that u is actually equal to the square root of x squared minus 3. And that'll be equal to negative 2 for the first equation. And the square root of x squared minus 3 will be equal to 6 in the second equation. Now, in order to solve those two resulting equations for x, we're going to have to square both sides of the equation. So when we do that, we just end up having what's underneath the radical drop out, and we'll square negative 2 to get 4, right? So we're squaring again both sides of the equation to get this new equation. Do the same on the other side, you'll get the x squared minus 3, and then you'll square the 6 to get 36, of course. All right, let's go ahead and give ourselves some room. Okay, let's continue the solving process then. I'll add 3 to both sides here. It'll end up giving me x squared is equal to 7. And then I'll need to take the square root of both sides. So it'll be x is equal to plus or minus the square root of 7, right? So we applied the square root property to get our first two answers, plus and minus the square root of 7. Here we're going to add 3 to both sides. and we'll end up having x squared is equal to 39, and we'll take the square root of both sides to get our second two answers, which is going to be plus and minus the square root of 39. All right, so those are our four solutions. So remember, we need to check our answers now, though, because the squaring process when solving can introduce solutions that aren't solutions to the original equation. So let's go ahead and check the plus and minus square root of 7. Okay, so if we have, let's say, the negative square root of 7, and we square that, then take away 3, then we have minus 4 times the square root of the square of negative square root of 7, minus 3 under the radical, minus 12 is equal to 0. When you square something like negative square root of 7, you're going to end up losing the radical, and the negative sign will become positive, so you just end up with what's underneath the radical, in other words, 7. So you have 7 minus 3, minus 4, times the square root of 7 minus 3, minus 12. Is that equal to 0 is the question mark, right? Well, 7 minus 3 is, of course, 4, and then you're going to have minus 4 times the square root of 7 minus 3, which is also 4, and that's minus 12. Does that equal to 0? All right, that will give you 4, then minus 4 times the square root of 4, which is 2, minus 12 is equal to 0. But of course, that isn't true, because 4 minus 8 minus 12 basically gives you negative 16. It doesn't give you 0. So the left side is not equal to the right side. That means negative square root of 7 doesn't work. But guess what? Whether this was negative or positive square root of 7, the same answer would have occurred because you're squaring these radicals, right? And squaring the negative sign is just going to make that positive anyways. So I don't think plus square root of 7 is going to work either. So we can eliminate these two answers. They're not valid. Let's very quickly show that the square root of 39 does work. If we take the square root or even the negative square root of 39, doesn't matter which one. Remember, squaring, it's going to make the negative or positive unimportant. So we'll have the square root of 39 with a negative in front of it, squared minus 3 under the radical, and then minus 12 is equal to 0. So when you square that negative square root of 39, you're just going to get 39. And then you'll have negative 3 minus 4 times 39 minus 3 minus 12 is equal to 0. So from here we can say 39 minus 3 is 36, right? And then you'll have negative 4 times the square root of 36 minus 12 is equal to 0. So that's 36 minus 4 times 6 minus 12. Does that equal to 0? Well, you'll end up having then 36 minus 24 minus 12, which is the same as saying 36 minus 36. So this indeed does work. So the square root of 39 is a solution for the problem. A negative square root of 39 is also a solution for the problem. As we mentioned, the negative or positive doesn't matter in this particular equation. So that means we have two solutions, plus and minus the square root of 39. All right, so let's do examples C and D next. All right, so example C appears to be in quadratic form. Let's go ahead and turn it into u is equal to x to the 1/3, right? So we substituted the x to the 1/3 for u. All right, from there we can see that u squared would indeed be equal to x to the 1/3 squared, which would then of course be x to the 2/3 because this power would distribute in, turning 1/3 into 2/3. Okay, so it looks like we can rewrite it as 3u squared minus 7 times u minus 6 is equal to 0. Then we'll try to factor the quadratic. So we'll have 3u and u, then factors of 6 that would split up into, let's say, 2 and 3. And then because it's negative, we'll have to have a sign of each. Let's go ahead and try negative and positive like that and see what works. So we'll have 2u here, and then we'll have minus 9u. And if we add those together, we do get negative 7u, which is the middle term. So that's the proper factoring. Okay, so let's go ahead and apply the zero factor property. We'll say 3u plus 2 is equal to 0, and u minus 3 is equal to 0. And then we'll solve those linear equations. So we'll have 3u is equal to negative 2, and therefore u is equal to negative 2/3. And also that u is equal to 3. All right, but remember, we're not solving for u, we're solving for x. So we're going to turn the u back into x to the 1/3 power. Okay, our next step then would be to cube both sides of the equation because we want to get rid of that exponent of 1/3. So we'll have x to the 1/3 raised to the 3rd power. We'll do the same to the other side. raise it to the third power, and we'll end up getting x is equal to, now negative 2 to the third power is negative 8, and negative 3 to the third power is 27. If we do the same to the other side, we cube both sides, we'll end up having x is equal to 3 cubed, and then from there we'll end up having x is equal to 27 simply. Okay, so now we need to check our answers to see if they do work in the original equation. To save time, I'm just going to tell you that both of these do in fact check out, so your answers are negative 8 over 27 and 27. All right, let's tackle equation D then. So equation D may look really complicated, but it really is, again, just u substitution, right? Because we can see that this guy squared would be the first term here, so it looks like an equation in quadratic form. So I'll say that u is equal to x squared plus 1 over x, and then I'll go ahead and apply u substitution, so it'll be u squared minus 6 times u plus 8 is equal to 0. We can try to factor this equation then. So we'll have u, and then a plus sign would indicate two negative signs, and then 8 would be factored as 4 and 2. So from here we need to separate the two terms. So we'll have u minus 4 is equal to 0 and u minus 2 is equal to 0. So we're just applying the zero factor property again here, right? And then from there solve to get u is equal to 4 and u is equal to 2. Now remember, u is the same as x squared plus 1 over x, so that'll be equal to 4, and it'll also be equal to 2. From here, we need to solve these two little equations. So if I multiply both sides by x, for example, in this first equation, I'll end up with x squared plus 1 is equal to 4x. If I do the same over here on the second equation, I'll have x squared plus 1 is equal to 2x, right? So we end up with two equations that look basically quadratic. So we'll bring over the 4x and we'll end up having x squared minus 4x plus 1 is equal to 0. And for the other equation, we can bring over the 2x and end up with x squared minus 2x plus 1 is equal to 0. Okay, so from there, it's just a matter of solving the two quadratics. All right, the first one is going to require that we use the quadratic formula because there's no way we can factor x squared minus 4x plus 1. So let's go ahead and say that x is equal to negative b, so it'll be plus 4, plus or minus the square root of the b term squared, that'll be 16, minus 4 times the a term times the c term, all over 2 times the a term. So that'll end up giving you 4 plus or minus the square root of 16 minus 4, or in other words 12, all over 2. And then from there we can basically simplify a little bit. We'll say 4 plus or minus the square root of 4 times 3 over 2. And then from there we can say that the 4 will come out as a 2. So we'll have 4 plus or minus 2 square roots of 3 all over 2. And then the final piece of this is going to be to cancel the 2 into the 4 and into the 2. So 2 goes into 4 twice, so we'll have 2 plus or minus, and then 2 goes into 2 once, so we just have the square root of 3. So here are our first two solutions to the equation. And for the other one, that one actually is factorable, so we can go ahead and call it x and x. Because it's positive, it'll be two negatives, and then 1 and 1. And so we get the answer x is equal to 1, and x is equal to 1. So basically the same answer repeated twice. So in other words, our final solution for this equation is simply 2 plus or minus the square root of 3, comma 1.